Today we're going to talk about section 2.5, which has to do with water. So water is one of the most important liquids in terms of life on Earth. And it's a very special molecule, and it's one of the biggest, most important molecules you're going to learn about all year long. So one of the key points of this section is that a hydrogen bonding in water gives it the properties that make it possible for life on Earth. So one important thing to note about water is that the molecules are polar. And we've talked about this a little bit already, but you know that because oxygen is a very electronegative atom, it's pulling the electrons towards itself. So polar molecules share electrons, but they share them unequally. So oxygen, being very electronegative, is pulling the electrons towards itself and gets to have them more than the hydrogen. This gives the oxygen a partial negative charge on the atom and the hydrogen a partial positive charge. The atom itself is still, the molecule itself is still neutral, but because of those pulls on the electrons, we get a slight attraction in positive and negative attraction that you wouldn't see on a non-polar molecule. And so when we have these multiple water molecules interacting with each other, because of those slight partial negative and partial positive charges, they like to kind of attract to each other a little bit by something known as a hydrogen bond. So that's when the oxygen of one water that's partially negative is attracted to the hydrogen of another water molecule that's partially positive. And they have this weak attraction known as a hydrogen bond that's constantly breaking and forming. The bond within the water molecule itself are polar covalent bonds, but the bonds between two different molecules are those hydrogen bonds. And those are constantly breaking and reforming, and they're responsible for a majority of the properties of water that we observe. There are 4 primary emergent properties of water that contribute to its suitability for life. So those are cohesive behavior, ability to moderate temperature, expansion upon freezing, and versatility as a solvent. And I'm going to go into each of those. So cohesion is when water molecules stick to each other or are attracted to each other. This is cohesion. And as you saw before, part of the reason why they're attracted to each other is because of those hydrogen bonds with those partial charges. This translates into a lot of properties of water, especially related to transport, because when water is trying to move upwards against gravity, especially like say in plants, it's traveling up the roots, up the stem, they're attracted to each other, and so the water can build up. But then also they can be attracted because of those partial charges to the sides of a substance called adhesion. So like when you have adhesive, it's something that sticks to something else. When water sticks to something else, it's called adhesion. So if you can imagine, adhesion is climbing up the sides, and then cohesion allows the water to rise up the middle. So if you think of a straw, for example, or the root of a plant, when you put a straw in a cup, you can see water automatically goes up the straw. That's due to cohesion and adhesion. The same thing happens in plants. Surface tension is also a result of the cohesive nature of water, and this is a measure of how hard it is to break the surface of the liquid. So as you can imagine, if the molecules are all stuck to each other in a very cohesive way, it's going to be a little bit harder to break the surface tension of that particular liquid. So what this allows is for a little thin film to be on the surface of the water, and you can see certain bugs like water striders are able to almost walk on water because of that surface tension. Another emergent property of water is the moderation of its temperature. So water can absorb heat from warm air and releases stored heat to cooler air, but considering the molecule itself, it's able to absorb and release a lot of heat with only a slight change in its own temperature, compared to some other liquids which gain and lose heat very, very quickly and change their temperatures very dramatically. If you need a little review on temperature from chemistry, remember temperature is the result of kinetic energy, the movement of molecules, and thermal energy is a measure of the total amount of kinetic energy due to that motion. So if you think of molecules moving very, very fast, those are going to be higher in temperature, and molecules that are moving a lot more slowly are going to have a much lower temperature. And when we transfer thermal energy from one body of matter to another, that's what we refer to as heat. So you can see some information in the textbook about calories, joules, kilocalories. This should be review from chemistry, but we use these measurements to measure energy and water. So water itself has a very high specific heat, and that's the amount of heat required to change 1 gram of that substance, its temperature, by 1 degree Celsius. So the specific heat of water is 1 calorie per gram times degree Celsius, which is actually very, very high, meaning it takes a lot of heat energy in order to cause the temperature of water to change. So either inputting a lot of heat and absorbing a lot of heat to rise the temperature or raise the temperature, or taking away a lot of heat to lower the temperature. And because it has that high specific heat, that's why water is able to absorb a lot of heat or lose a lot of heat without changing its temperature. This specific heat is due as well to hydrogen bonding, because heat is absorbed when hydrogen bonds break and heat is released when hydrogen bonds form. So the breaking of bonds is an endothermic reaction and the forming of bonds is an exothermic reaction in this case. And so because hydrogen bonds are always breaking and forming within the water, that kind of causes the specific heat to be a lot higher, and that keeps the water at a more moderate temperature, which allows us to continue with life. Water also can transform from a liquid to a gas, and so that happens through the heat of vaporization. And when liquid evaporates, the surface remaining is cool in a process called evaporative cooling. And so because of this particular aspect of water, that also helps organisms manage their internal body temperature, because evaporative cooling, aka sweating for humans, helps keep them cool and regulate their life. Ice can also float on liquid water. So typically when you have a solid substance in the same substance as a liquid, it will sink because it's more dense. But because the hydrogen bonds in water make ice very ordered, the ice is actually less dense than liquid water. So this is really important, because if ice sank, then eventually when it got cold, all the bodies on Earth would eventually freeze solid and we wouldn't have life on Earth. But because life floats, or ice floats due to those hydrogen bonds forming that nice lattice structure, life is able to continue on even underneath the ice. Water is also sometimes known as the universal solvent. So when we have a solution, that's basically a homogeneous mixture of liquids, but the solvent is the dissolver. So water is a great solvent. It can dissolve a lot of things. Solute is the substance that is being dissolved. And I like to remember this. I don't know why this works for me, but I remember solutes seem like little particles to me. So I just remember the solutes are the little particles that are being dissolved and the solvents doing the dissolving. In a cup of water and sugar, water would be the solvent, sugar would be the solute. When you're making hot cocoa, if you use milk and cocoa powder is the solute, milk is the solvent. And then anytime we have a solution where water is the solvent, we just call it an aqueous solution. One of the reasons why water is such a versatile solvent and is able to dissolve so many things is due to its polarity, because since it is polar, it can form hydrogen bonds easily. So it doesn't just have to form hydrogen bonds with other water molecules. It can do the same with any other molecule that has a slight positive or negative charge. And then in doing so, helps the molecule dissolve and dissociate into individual molecules and then eventually compounds, etc. So this kind of shows you when salt is together, it's sodium and chloride. But because those are two ions, this is an ionic compound, when we put salt in water, the positive hydrogens, partially positive hydrogens, remember they're not ions, it's just because it's polar, of the water are attracted to chlorine, and the slightly negative oxygens are attracted to the sodium because that's positive. And so eventually the water comes in here and breaks apart all these bonds between the sodium and the chloride. Water can also dissolve other compounds made of non-ionic polar molecules. So even proteins can dissolve in water as long as they have either ionic regions like the salt or polar regions like water itself where it's just a slight charge. So you can see here that there's some polar regions of this protein. It's being dissolved by the water in the same way. Partial negative gets dissolved by the hydrogens, and partial positive part gets dissolved by the oxygens. One thing we've talked a lot about in regular biology is hydrophilic versus hydrophobic substances. Hydrophilic substances have an affinity for water. They love water. They can dissolve in water. Hydrophobic substances do not like water, and they will not dissolve in water. So another term that you're going to hear a lot is like dissolves like. So a polar substance can dissolve a polar substance. Similarly, a hydrophilic substance can dissolve a hydrophilic substance. So water can only dissolve other polar substances and also some ionic because they have polar qualities. But water cannot dissolve oil because oil is hydrophobic. It's non-polar. And so in order to get rid of something with oil, you have to get rid of it using something else that's non-polar. One thing that happens to me all the time when I go to the beach in the South Bay is I get tar on my feet. Tar is a type of oil. And when my friends who aren't science teachers would go home, they would always tell me, oh, you need to put ice on the tar and it'll come off. Not so. Ice, water is polar. Tar is oil, non-polar. I took some vegetable oil from my kitchen, rubbed it on the tar spots on my feet, and the tar was gone almost immediately. So if you know a little bit about polar, non-polar, you can solve a lot of your cleaning problems. Most of the time when we have chemical reactions, it requires some solutes to be dissolved in water, at least in organisms. And so this depends a lot on the number of molecules that are present in a particular aqueous solution.